Hello, future toppers. Let's make maths simple, intuitive, and fun together. So, we got wholesome new problem which says let f of x equals to this x belongs to R, then the set of all values of x at which the function g of x equals to f of x is not differentiable. Now, look at this how we will handle these kind of situations. So the idea is whenever you are handling question of differentiability, you can go by two methods. The method number one is using graphical approach. You have to draw a graph of the whole question, and then if you are have now you have to observe the graph. If you are having sharp turn, function is not differentiable. At end point, function is not differentiable. Okay, if it is discrete, means it is isolated part, it is not differentiable. Okay, the moment you will draw the graph, you can directly observe at what points the given function is not differentiable. Then we have second approach, that is a mathematical approach. So you will break down your function into various rooms, piecewise function. Then you have to do what? You have to find out the doubtful points. Now at doubtful points, you will do the differentiation, substitute the point. If both comes out to be equal, then you can say that sir it is differentiable or not differentiable. So first question I'll go with both ideas. Okay, so first we have to find out who is g of x. So who is g of x? G of x is f of x. Now look at this. Now we have to replace x with f of x in the function f of x. So it is 15 minus mod f of x minus 10. Look at this. So we can write 15 minus mod. In place of f of x, can I write 15 minus mod x minus 10 minus 10. Okay. Now let's simplify things. So we got 15 minus mod. 15 minus 10 is 5. 5 minus mod x minus 10. Okay. Now look at this. You have to break down this function. So my idea is first you have to break this rule. So look at this. You know that modulus function if like f of x is equal to mod x, it will open with positive sign if x is greater than equal to 0. If x is smaller than 0, it will open with minus sign. First it will multiply with minus, then it will open. So suppose that I am asking you to find out the critical point. So critical point means at which point it will become 0. So if you take x as 0, x as 10, it will become 0. But after 10, take any number after 10 in place of x. Suppose 11. So 11 minus 10 will become positive number. So after 10, this function is positive. Before 10, it is negative. So you can break down your function into two rooms. Means room number 1, that is minus infinity to 10. No, no. So in this room, your function will be negative. This part will be negative. So you will multiply itself with minus sign, then you will open. So this minus and that minus will become plus. So you will be having g of x equals to 15 minus mod 5 minus minus plus, and then it will open x minus 10. Okay, now you can break. So you will be having 15 minus mod x minus 5. Okay, now second room from 10 to infinity. 10 you have ignored, so you will keep 10 this side to infinity. So in this room it is positive. So if it is positive, it will directly open. So g of x will look like whom? It will be 15 minus mod 5 minus x minus 10. Okay, so your function will look like this. So wait a moment. 15 minus 5 minus x plus 10. So it will become 15 minus 15 minus x. Till this part, I hope you guys are okay. Now look at this. Now we have to break down this mod. So if you'll observe, the critical point is 5. So after 5 it is positive. Before 5 it is negative. But after 5 you will go till which point? 10 only. You cannot go beyond 10. Because this function is defined only in this room. Okay. So from minus infinity to 5 and then 5 to 10. So look at this. So room 1, x belongs to minus infinity to 5. No, no. In this room it will open with negative sign. So this negative will become positive. Okay. So we will have g of x as 15 plus x minus 5. And then we will be having 10 plus x. So this is first room. Now from 5 to 10. So x belongs to 5 to 10. 5 is yes because you have ignored in previous room. 10 is no. In this room it will open with positive sign. So g of x will become 15 minus x minus 5. So it will become 10. No, it will become 20. That minus will become plus. So it is 20 minus x. Okay. Now look at this. If you'll observe, the critical point is 15. Now be super slow. So behind 15 it is negative. So take any number below 15. Take 10. So 15 minus 10 is a positive number. Means behind 15 it is positive. Means x belongs to 10 to 15. No. Sorry, yes, no. So it will open with positive sign. So we will have g of x is equal to 15 minus 15 plus x. This thing gone, so it is x. Okay. Then we have next room from 15 to infinity. So x belongs to 15 to infinity. And 15 is yes. So from 15 to infinity it will open with negative sign. If you will take 16, so 15 minus 16 will become negative number. So it will open with negative sign. It will become positive. Negative, negative, positive. Okay. So g of x will become 15 plus 15 minus x. Okay. Wait. In previous room it opened with negative sign. In this room it will open with, no, this is correct. So this is 30 minus x. Okay. Now if you will observe, you got how many critical points? The doubtful points are 5 because at 5 you have changed your definition. At 10 you have changed your definition. At 15 you have changed your definition. So you have to, first I will go with mathematical idea. So what I will do, I will differentiate and then substitute the point. So now I will find its differentiability at x equals to 5. So g dash x will become what? 10 differentiation is 0, x differentiation is 1. Okay. Now here, sorry, at x equals to 5. Now g dash is 0, g dash is 1. Now g dash for this, it will become what? 20 is 0 and minus x is minus 1. So it is not equal. LHD means what? Behind this blue function. Behind is blue function, after is yellow function. So you can clearly observe that it is not equal. So it is not differentiable at x equals to 5. Now at x equals to 10. Now for LHD you will be using this definition. Just do the differentiation g dash x. You will find out that 20 is 0 Differentiation of 20 is 0, minus x is minus 1. Then for RHD, g dash x is equal to 1. So again it is not equal, so it is not differentiable at x equals to 10 also. Now at x equals to 15. So what we will do for LHD g dash x, we will use green function. Green function differentiation is 1. Then this g dash x for RHD, we will take this idea, which is minus 1, which is not equal. So I can say that at these 3 points, it is not differentiable. So given function is not differentiable at 5, 10 and 15. So this is my idea. Now look at this. This is mathematically how we will solve. Now let's try to solve by using graphical approach. So we have doubt at 5, then 10 and then 15. So look at this. At 5 it is what? At 5 it is 15. So it is 5 comma 15. Now at 0 means behind 5. At 0 it is 10. So 100% graph will go this way. Correct? So this is the graph. Now from 5 to 10 we have to draw this graph. Now suppose that at 5 it is what? At 5 it is 15. So it will start from here only. At 10 it is 10. So it is below that one. So suppose this point. So it is 10 comma 10. Okay. Now we have second function, next function. Okay. We will use this. So at 10 it is 10. At 15 it is 15. So again at same level. Okay. Now after that we will use another definition, which is, sir, at 15 it is 15, means start from the same point. At 30 it is 0, means it will go this way. So look at this. This is the graph of a function. And clearly you can see that at this point, and this point, it is having sharp turn. So it is not differentiable at given function is not differentiable at x equals to 5, 10, 15, but it is continuous. Okay, I hope the idea is clear and you guys can handle similar situations. So from now onwards, if you will have any question from this department, you can handle accordingly. Okay, it's on you. You want to go with graphical approach or you want to go with mathematical approach. Whatever is convenient for you guys, just go with the flow. Okay, so see you guys in next session of MathFlix.